So today we're going to talk about the solution for Adobe, and that is the Adobe I/O API Gateway, which is based on NGINX and with Lua modules. And we're just going to look on how is that going to shape the way that we can run microservices in the cloud. If you are attending this morning, the last talk of Christopher Brown, he touched a little bit on the containers and Mesos and Kubernetes. So if you haven't seen that one, it's really good to watch. I'm just going to pick it from there and actually show something in like running. Just that you can take it as an experiment for you right now, but it's just basically sharing the capabilities and the vision that Mesos brings and the role that the NGINX-based API gateway can play. So with this, let's get going. We're using Adobe I/O, and this gateway that I'm going to demo today is used right now to proxy pretty much all of the traffic from the three clouds: Creative Cloud, Document Cloud, and Marketing Cloud. And all the mobile traffic is happening. If you seen the demo this morning, this is my favorite demo on how you can remove people from the picture in an easy way. You just select them and then just fly away. So we build these cool APIs, and we're just thinking, how can we make it easy for developers, and how can we as engineers can push to the market microservices in a scalable way and in a faster way. How many of you guys are here writing microservices today? All right, quite a few. How many developers do we have today in the room? If you're a developer, okay, you're probably right. Okay, thank you. So the Delta, you don't write microservices for now. Okay, cool. And DevOps guys? All right, cool. Okay, nice audience. All right. Let's speak a little bit about the lifecycle of a microservice, as we know this. Like, if you create an API, and by the way, for today's talk, when I'm going to speak about microservices, I'm going to speak about APIs. It doesn't mean that whatever we're like playing with today, you cannot use it for something else like background job or tasks and things like that. But just allow me to call it microservice and API to be the same thing in the context of the presentation today. So we have somebody that has a cool idea, builds an API, and a developer that wants to consume it. And usually you put some security. You can imagine SSL in a simple shape. And then you may want to see which application and which user is accessing the service, and then as the service is going on, you may look on the usage data and on the performance data. And then if you're really popular, then you might want to put some mechanisms in place for throttling and rate limiting and maybe other traffic shaping feature. When the story looks like this, it's simple. It's nice, you get started, it looks beautiful. I'm going to complicate the picture a little bit, and I'm going to add like some more microservices and some more developers. All right, and you can add more. Big organizations today have a lot of microservices running. So at some point you notice that there are like some common things that you either implement into each microservice every time. Like if you want to capture a new metric, you just go put a new metric. If you want to capture another one, you go on each service and add that capability. Or what we try to do at the API platform at Adobe, we try to take these things that I'm highlighting right now and take this picture and make it look something like this. So we have been basically looking at what are these common things that people put in the APIs, but which are not necessarily what the API is doing. Like I just showed you an image processing, all right? Putting throttling application user authorization into an image service is kind of a bit of a waste, like to be concerned about that. So we group this like I showed you. For the developer side, we have a developer console. On the API side, we have an API console where people expose their APIs. What is on my right-hand side is only internally. What is on my left-hand side is also publicly, so you can actually watch it. And this is what we call to be the API platform at Adobe. In the center of it is the API gateway. something that we're going to play with today. But just because we're not going to show the developer and the API console, I'm just going to show you a few screenshots. For instance, this is creativesdk.adobe.com. It's the public-facing portal where people come and create apps, and you can actually use the APIs that we showed this morning. If you create an application, you can create your own mini Photoshop, basically. Seriously, like. And people come here to the developer portal. They create an application, as I mentioned. They view the usage data and how many users are using it. On the backend side, we have the API console. This is only available inside Adobe, and this is where people come and expose the service. It's not really the key topic of my talk today, but I just wanted to give you like the whole view of what we're doing. It's not just the gateway, but there are also these other components. And here as an internal team, you may come and see which application is using. We split by region and some usage and performance metrics. All right, so these UI aside, now I'm going to focus on the gateway. So the question is, how do we make it easier to scale the microservices? I'm not sure what your experience is right now to push new services, but there are some mechanics when you start from zero, like for nothing. Let's say you don't have any environment at all, right? You need to decide where do I want to run. Do I want to run in the cloud or a public cloud, or do I run on my on-prem data center? And then you have to get the CIDR block of IPs probably, and there's like these steps that we noticed, and we're just thinking really like if you want to change faster, what it would make it, what it would take to actually deploy faster. So with this in mind, we started to look at the workflow that would let people write microservice, containerize them, and running them or deploying them. And in my talk today, I'm going to focus on Mesos and just repeat this cycle over and over, streamlining it, make it better and better, so that people can write microservices in their language of choice, containerize in the container of choice. I'm showing Docker right now because it's the most popular, but it doesn't mean it's the only one that we're looking at, and Apache Mesos. All right. Quick question. For how many of you Apache Mesos is the first time you hear of it? That's awesome. Okay. Did you guys play with it so far previously? Nice. All right. So for those of you who haven't used Apache Mesos, is a way to look at it is that you program for the data center just like you program for the operating system. And in today's talk, I kind of took this parallel between the computer and the data center. So the data center is your computer, like, and on the computer we run services, right? In the cloud, those are like microservices. On the computer, you have a kernel, and for today's talk, you can think of Mesos as the kernel with a star. I'm going to get back to that star. Operating system is whatever you use, like you can think of them like the Mesos frameworks or Marathon. If these words are new to you, don't worry because we're going to play with them today. The services are the microservices, as I mentioned to you, and the traffic controller is the API gateway. And this gateway facilitates the inter-API communication and does the traffic shaping, the API key management, and the things that I showed you previously. My last slide before jumping into the demo. We're going to set up today a mini data center, and because it takes a little bit of time, I pre-set it up for the demo. We're going to have 3 zones. We're going to have the admin zone. The admin zone is like, for the computer, allow me to say, it's like the control panel. It should be pretty well protected. This is where you control some settings about your data center. The private zone is where the APIs run, or the microservices. And the public zone is the buffer, the connection point with the users. We call it the public zone because we are in these yellow boxes here. Today we're going to write we're only going to run the gateway. The gateway is the only way into our computer or data center. And then in the private zone, we're just going to run the microservices. The reason why you see this gray rectangle is because today we're going to run one API gateway, a couple of services, and I have a single instance on the admin. They can be scaled, so on the distributed nature and scalability, there's no problem here. But for today, just to keep it simple, I did only that. There are simple ways to get started, and just pointing you to this. To spin up a cluster, for some people it might seem difficult, and I would like to challenge you to try it out. So I'm going to exit the PowerPoint right now. Okay, that's it. I'm done. No more PowerPoint. You can see my screen. All right. On the Mesosphere's website, you have an Amazon setup, and you can get started for free by just choosing a key pair and selecting an Amazon template and select which region you want to deploy, for instance, and how many masters. The masters are like the admin area that I showed you about, but for today I only selected one master. And then when you click Get Started, that's pretty much all you have to do. And then you can take a coffee break and come back maybe in 10 minutes, 20 minutes, I'm not sure how long it will take in Amazon to spin. And then you're up. Once you have this, once you've done this, if you go into the Amazon console, you'll see a few nodes, and I labeled them just to make sense. There is the admin master zone. This was what I was showing you on my right-hand side. It was the admin zone. The nodes that have a public IP are in my public zone. Oh, there you go. Still not used with this UI. Okay, can't move it. Okay, but here you see some public DNS names, so that means that I have some nodes in my public zone, and then I also have some nodes. These guys that don't have any public DNS, they are all in my private zone. So what I got so far, got this data center, I got some compute power internally, and I have also some public nodes that can take my traffic. For you to see this in Mesos, it's quite easy. You just go on Mesos, and by the way, just FYI, what I'm showing right now, I also put screenshots in my presentation. So if you guys just want to recap this, you can look at the slide deck. So in my cloud currently, I have my quote-unquote computer, right? I have 28 CPUs, this much memory, and it looks like currently in use I only have 4, so I have like 24 spare. So now I have my Docker containers, right? And I would like to run a microservice, and let's say it's a Hello World microservice. To run it, I'm going to use the Marathon API. Marathon is like this, you can think of it if it's new to you, like a web UI that you use to spin up your instances. The important point that I wanted to make, and if you remember, I was saying that Mesos is like the kernel, but take it with a small star. And the reason, what I want to say is that right now I have these tasks running. If I were to shut down Marathon and Mesos, nothing will happen. My Docker containers will still run, which is not the same thing with the kernel. Okay, that's a different thing. So Mesos and Marathon, what they help me with is they help me in two things. They find the excess capacity that I have in my cloud, and they schedule my tasks there. And then Marathon ensures that if I say I need to run 2 instances, right now I'm only running 1, but if I say I want to run 2 instances, and for some reason, of course, in the cloud, sometimes they die, right? Marathon makes sure and monitors them and makes sure that if one died, it will spin the second one. So that's the nice thing. And it also has this nice UI that shows you, what things are working and what not. All right, so right now, I'm going to destroy my applications, but before, let me just make sure I have internet. Okay, I have. Hope I won't feel sorry. All right, let me just delete the gateway. I'm going to destroy my Hello World application, and I'm going to keep the analytics. Let me see, I don't have an API key. Okay, all right. My script for today, which you'll find in the presentation, is also on Gist, and you'll find a link there. This is my script. So all I have to do to run the script is basically configure the 2 Marathon hosts. There is one internal and one external. The only difference is that the internal one is used only within my cluster, and it's just an ELB that I have here that is capable to open the ports so that my gateway can communicate with my Marathon host. This is pre-configured for the demo, and in order to expose the APIs, probably this is a common pattern, we use CNAMEs. So if I want to access my application, which I'm going to show you, I'm going to use something. If my application, let's say, is called NGINX, I'm going to access it by going to nginx.api.any domain of my choice. All right, so let's install actually the first Hello World application. There is a simple curl script that I got here. Make this a little smaller. Is that okay for you, size-wise? Do you want me to make it bigger? Okay. So what I'm doing right now is I take a Docker container. I take an image. I just picked an image from Docker Hub. And I am asking my Marathon to find a place in Mesos where it has like some CPU capacity to run. And I'm asking for 0.5 CPUs. How cool is this? Only 500 megabytes of RAM, and I'm going to say I'm running one instance. Just to keep things short, I'm going to take this and paste it here. This is the API, and right now I got an answer back. If I go to Marathon, I should see a Hello World application that is running one instance. If I want to scale it, oops, I go to scale, I select 2. And soon enough, I'm going to have 2 Hello World apps. At this point, what I have is 2 microservices running in a private zone in a cloud, right? And now we have to access them. And the cool thing at this conference is that we love NGINX and we can get excited about this. So let me go ahead and do this. Look, like right now, if I access this, of course, there's no access. It's a private IP, not a public IP. And notice my services can also run on different ports. That's not a problem. I'm going to install the gateway now so that I can access my Hello World app. Going back into my script. Here, I am going to install one instance of the gateway. Okay. And I'm going to run it. What is particular about this instance is that I want this instance to run on my public zone. So to do that, I've configured Marathon with a tag, which is called slave public. So every time I deploy a Docker container with this data, I'm basically telling Marathon to run in the public zone. And because I also mark hostname unique, I'm making sure that there's only one gateway in each node. And the reason for that is that I run my Docker container in the host mode. And this is for performance reasons. Like if we have one reverse proxy that does a lot of traffic, you might want to run it in this mode to get the most of the performance out of it. Okay, so it's running on port 80. So now if I check on Marathon, if this is running, I have the gateway running here. And remember I told you that I've created an API, and I've given this talk at the ContainerCon as well, so that's why it's called ContainerCon Adobe. So if I go hello world.api ContainerCon, I load, I have my hello world here. All right. Now, if I go and destroy the application, which I'm going to suspend, okay, it's gone. The gateway has like kind of a pooling, like every five seconds, go into my cluster and checks which services are running. At the moment, we baked in this service discovery inside of the gateway, and it's hidden under a feature flag. If you give the gateway a Marathon host environment variable, the gateway tries to look in them and tries to get the services. We're looking at ways to do composition with Docker, which is not solved, and just sharing this with you. Like one path that I'm trying is to see if I can run 2 containers on the same host, give them a shared memory zone, and see if I can run some workers between that shared memory zone and do something with 2 containers in a way like I'm composing, but it's not one Docker container, there's multiple Docker containers. You can think of it like Docker compose, but in a way that they can actually communicate on a high speed. So the speed that I was able to get on my local machine with this using like a high performance 0MQ, right now I was like at 30,000 a few days ago. I just tweaked some settings in NGINX, and now I'm at 50, 60,000, and I hope I'll reach 100,000. And that is not that 50 wouldn't be enough, but just I always do this exercise to see what would it take if I want to run 100,000 requests a second. And by the way, the current gateway that is being used today, at least on my local machine, if I don't do reverse proxy, it can reach 100,000 requests per second with just 2 CPUs. And that is because I'm using an Alpine Linux version, which is opinionated about glibc and versus another library, muslc, I don't know how to spell it. And that does give a lot of performance. Like the things that run on my local machine, which is like bare metal, is really bare metal. My Docker runs in a VM virtual box. So take this, okay? If I run on my local machine, is less performant than if I run in Docker. How cool is that? The day that I saw this, I was comfortable with this technology. You know, it has some leaks, all right, but you know, I love it, and the leaks were just going to work around them. And really, like some of the security leaks, I'm going to scale this back up. Some of the security leaks that are in Docker, we kind of try to hide them behind running Docker in only private zones and not making those machines accessible, but only through the gateway. So we kind of try to mitigate some. Of course, we cannot solve the whole problem, but just sharing this with you. All right, my nodes are back up. If I refresh this, I got my hello world back, and notice the 467. If I don't have a cache, and if I refresh again, I get the other host ID, whatever. So you see that the gateway was able to identify this and look. Now let me show you what's happening actually in the gateway. There is a script that runs constantly, as I said right now. We'll probably integrate with console and Docker and you name it through Docker composition through a pattern that we're going to find. But right now it's just going to marathon and constantly ask what tasks do you have running, what tasks do you have running. Add maybe a 5-second break. So as a result of that, okay, I'm going to go inside of my Docker. Container is not because I just restarted. So, okay. I have another Docker container. I'm going to go inside, and I'm going to open a file, which is an API gateway environment config, and there's API gateway upstreams. And this is a output, like basically we take the marathon configuration, and the hello world is here. You can see each one on its port. So it's basically NGINX streaming. Okay, there's nothing that we actually did to NGINX so far to get to this point. It's just adding that script and creating the upstreams and proxy. And make this, of course, highly performant. Now, looks like my time allows. Let's protect this API. Okay, let's say we want to put some API key in place. I have a configuration file as part of this gist. All right. Here it is. It's a hello world microservice, and it's nothing else than just narrowing down to hello world.api.anything else, and so that the requests that come on hello world will stop on this vhost. And let me get this curl command that I put here, and just to speed things up, I'm going to save this configuration file in hello world microservice.conf. At this point, the gateway should automatically figure out that there has been a change, and I can show you in Mesos. This is another thing that I love about Mesos is that I don't have to SSH into the box to get some logs out. And I think it's right here. And you see my whatever service discovery. I'm also watching for the files that change on the host. So that's how I'm able to see that this file has been just added and the gateway reloaded. So I'm going to close this back to my hello world application, and if the API gateway restarted correctly, I should get the API keys required. All right. All right. What's extra here? I actually have to show you this. So this is our touch point. This is where we actually dived into NGINX to add 2 things. I'm not going to switch to big screen because it's going to take a while, but I want to show you this. So we've taken NGINX and the OpenResty, especially for the Lua module. It doesn't mean that we're like dependent on the whole OpenResty. We're actually going to make this to work in NGINX Plus too. But this is our current setting. And then we've added some custom modules. One of which is the request validation, which you saw that came into and said that the API key is required. The request tracking is for tracking purposes. We can do another webinar maybe on this because it's worth a full hour on what we did. And the logger is just grabbing the data, the user data, and the performance data and put it somewhere. So what we did in NGINX, we want it to be as less intrusive as possible, okay? Let me actually go back. So NGINX is stable, very stable, powerful, all right? We didn't want to touch that. What we wanted was to just imagine if we can have like some description like this in the configuration file. And if I want to protect an API under API key, just say, let me make it bigger for you folks in the back. You see, I have my server name here, and we just wanted to say, for this location, I want to validate an API key, I want to validate maybe a token, the service plan, throttling, that's it. The rest of the magic, it's a proven pattern, it's NGINX. So now if I go back into my configuration file, I can show you this right here in my first location, doing some stuff, and validate API key is on. And then on the access phase of NGINX, you guys should be familiar with this maybe, we just have our own object validation and validate request. That's it. And this just looks at the things that are defined and validates them. So in order for us now to manage the keys, I can show you this is real quick. We keep the keys into a Redis cache. The Redis is not our database. Don't make Redis a database. I can give you a paper on Call Me Maybe why Redis may not be the best choice for database. But for caching, super fine. Actually, we never had and my colleagues can keep me honest here, we never had a failure with Redis in this past year, like since late 2013. We never had a failure, but we try, like we've also implemented 2 layers of cache. We have a L1 layer of cache in the gateway, and then only once in a while we go to Redis. So we try to make these round trips as limited as possible for performance reasons. That's why. So to have an API to do the key management, I have my script here. I'm going to install Redis, and I'm going to add the key into Redis. So allow me just to go through that. Okay. I'm adding a Redis instance. We've also programmed the gateway by convention. So this is like, take it as a quick start, okay? We're also learning like you, okay? So the gateway by convention is looking to see if there's any application which is API gateway-redis, just by convention. And if it sees that, it will start to check the API keys from this instance. Let me scale. We just need to wait a little bit for it to be deployed and download. And while that happens, I will be adding a key. There is a simple API that we developed in the gateway. Usually this will not be publicly exposed. I've exposed this for you, but what I'm doing is just I go on the API gateway cache API key, and I'm just adding a key, and I'm going to say application name. I'm going to say app1 NGINX conf. This application name is important because the analytics data is going to be based on this. And the service ID is just saying only allow this API key for the service ID. It's nothing really too complicated. All right, I have my key. So what I can do, then I can use key1. And if everything is, if I've done everything correctly, API key equals key1. There you go. I got access, okay? If I do whatever, key2, of course, this is not in the cache, it won't work. All right, so now let me go to key1. We're almost on top of the hour. Okay. As part of the script, if you guys want to play, there is a script down below here that also shows how you can install Graphite and Grafana. And the reason why we went with this is because it's open source, it's easy to get installed, it's easy to get started. It can take you so far, so you can use it like to start. And then we're also building in the gateway this integration like with messaging. ZeroMQ is in place, Kafka is going to come. We also integrate Kinesis and SNS if you want to push things out. Yeah, I know I should mention something as a preview. My colleague is not here, Frank Wee, which was on the stage, but we're going to launch an Amazon SDK soon for NGINX, which is written in Lua, and it works perfectly fine. We've been using it for many, many months. And you can actually even proxy Lambda calls from the gateway, which is a nice way to get started with a microservice. If you don't want to run it, you just write in a Lambda, you put NGINX in front, you go to there. When your service becomes popular and it hurts your budget, you can just write your own stuff. More to come, but just a heads up. So the script here has whatever is needed to put a graphite instance in place, and Grafana, which is the UI, on top of it. And there's also, it's too bad I cannot minimize this. I'm going to scroll down. There is a optional Grafana dashboard that you could install if you run this curl command, this long curl command. What it gets you at, it's this Grafana dashboard. And let me say last 15 minutes and put it on auto refresh every 5 seconds. All right. Notice here I have application 1 NGINX conf, which I just created, right? If I generate traffic to it, yeah, my network connection is not that great, but let me just try to make some. I could hit more. At some point, you're going to see that, you see, I just made this many requests. There's a little lag because we don't send the analytics right at the same time. Again, we've been testing this at hundreds of thousands of requests per second, so we're careful when we send the data. We send them in batches and all these things to be able to reach that throughput. So there you go. I have my NGINX application. If I am to add another key, the same thing will happen. Automatically, the application name is going to show here. These are the top apps. We also show the top services that are being used. Very useful thing. You want to see if a service is really used and it's really worth maintaining it. If I'm stopping here, you see the Hello World and API Gateway Grafana and Graphite. Grafana is just the UI on top of Graphite, so Grafana keeps calling it. So that's why you see that they're also used here. And then we also show, like, you can show metrics like 500 errors, 400 errors. We have latency metrics and some other metrics which are already baked in and built in, but they're just not part of the dashboard. But just to show you some things that are possible with Mesos and Marathon and how easy it's actually to get started. It might take you maybe one evening when you want to learn something new to just get comfortable with Mesos, and then you can run these things, and they scale really, really well. So before I switch to the questions, I just have a few takeaways, and let me just bring this slide. Some things to, is it shown here, there? Okay. It's really funny on my screen. So let me just show this. So, three things to take away. Think holistically at the microservices. It's very tempting for a team if it does a service, and it's really cool to put a lot of things there and just not worry about the rest of the microservices that are in an org. This is a common problem, but just I think this is one of the lessons learned. Then, second, does my microservice really need to care about? This goes on the principle of keeping the microservice minimalistic. And we built in the gateway like the auth token provider. No, it's not the provider, it's the validator. For instance, what that does is that if an OAuth token comes into the gateway takes the request, validates the token, decorates it with some fields, which is like the user ID, and other user info from the token, and then forwards that request with these headers to the service, so that the service doesn't even need to care which identity provider is it talking to. That makes some nice patterns, like a company may come with a different authentication mechanism into your organization, and all you have to do to support that is just a single layer, which is the gateway layer. So we build some nice patterns around it. And three is less is more. The lighter the microservice, the easier it is to change. And this goes also to the speed of change. And I got a dear code here from this person that I cannot read on my laptop. The ability to learn faster than our competitors may be the only sustainable competitive advantage. Just something for you to think about, that the speed of change does matter, and the faster you learn how to do things in a stable way, the easier and the more success you're going to have. So with that being said, I'm open to your questions if you have. All right.
Why the choice of Mesos and Marathon versus throttling? Did you do any evaluation?
That's a great question. So the question was, why did we pick Mesos and Marathon instead of Kubernetes? So some people look at them as being one versus the other. They actually work together. It was easier for us to work with Mesos and Marathon for our purposes, and the teams in Adobe, they have a preference for this. I guess the vision is to actually run them together, because Kubernetes brings this concept about pods, which in some cases is useful, and some other concepts as well. But when I say we, like especially the communities inside Adobe, we think of them as like working together, not one versus the other. Okay, the question was if we used Redis to store the keys, and the answer is yes. We use Redis as our cache. In a production system, we also use Redis. We actually use the Elastic Cache from Amazon. Yeah. But we don't go too often to Redis. We try to limit. This is very important if you want to reach a high performance. Yeah, so we just try to use known technologies which are proven, which are stable, and they perform pretty well. And we have quite a big success, at least inside Adobe. And we also started to make this open source, so that, because like we build this thing which we believe is cool, but we're a little bit concerned that maybe we build just the Adobe mindset into whatever is there. And we would like the community feedback. So that's why we're starting to make some things open source. Probably there are two big things that are worth mentioning right now. Is we have a distributed rate limiting and throttling solution that goes into your whole cluster, and doesn't do only throttling, but you can also do like application plans and user plans. An application plan may be, let's say you work with an org and they have an iOS, Android application, just as an example, and you can say that particular org can only make 1,000 requests a day, for instance. And the same model for the user plans. You can say if you can categorize the users, you can say if you're a free user, I give you a limited number of API requests, but if you give me money, if you're a paid one, you can get more. Right, so we actually built this into, and we built it on top of ZeroMQ. We have a special message broker that does it. So there's more to this, but I just wanted to say that this is one thing. And the second thing that we're also looking to open source is this management around the NGINX, which in an organization, you may not want any team to just be able to mess around with the configuration file. So we built this UI that is kind of guiding you through and exposing the APIs. But right now, what you can get is the API gateway on the open source, and I can bring the website. Here. Yeah, you can have the gateway. You can have the request validation that gives you API key management with Redis and OAuth token validation. There is also some HMAC, which will make more sense. If you do OAuth 1, this is very good, and we're right now working out to push the ZeroMQ adapters and everything to support the throttling and rate limiting. Yeah. Thank you. It's not on the screen. Yeah, that's a great. Thanks for mentioning. All right. This is our Git repo. Thank you. All right. If there are no more questions, we're almost on time. Thank you very much for coming. I hope you learned something useful. And if you want to connect with us, right now you can use this channel. We're going to probably create a more collaborative space. But right now, if you want to use the software, you can just get it from GitHub, or just come here, get my contact. And we're more than happy to talk with you and discuss about this. So once again, thank you for your time, and enjoy the conference.